So in this problem, we need to verify that these 3 points do not form the vertices of a triangle. So what we'll do, we'll assume that they form the vertices of a triangle. So let us consider a triangle, and the triangle has the vertices A, B, and C such that the coordinate of vertex A is 2, 3. Coordinate of vertex B is -4, -6. And coordinate of vertex C, let it be 1, 3/2. Let's try to find out the length of each of the sides. For this, we'll have to use the distance formula. So this is specified here. Let's say we have 2 points, point A and point B, whose coordinates are given. Then the distance between the 2 points, which is a straight line, is given by this particular formula. All we have to do is take the square root. Underneath the square root, we'll have to take the square of the difference of the x coordinate. So that's the x2 minus x1. And then add it to square of the difference of the y coordinate, which is y2 minus y1. So let's use this to find out the length AB. So AB is going to be equals to, we'll take the square root. So underneath the square root, first we'll take the difference of the x coordinate. We'll start with the x coordinate of B, so that's -4. And from it, subtract the x coordinate of A, so that's 2. So we have -4 minus 2, we're going to square this result. And we're going to add it to the difference of the y coordinates. So we'll start with the y coordinate of B, so that's -6. And from it, subtract the y coordinate of A, so that's 3. So we have -6. Minus 3 whole square. Let's find out this value. This comes out to be, so we have square root of the -4 minus 2, so that's -6. -6 squared will be 36. This is added to, so -6 minus 9, that's 9. 9, -9. -9 squared is going to be 81. So this comes out to be square root of 117. Fine. Now we will try to find out the length BC. So BC is going to be equals to, same rule, all we have to do is first take the square of the difference of the x coordinate. So we'll start with the x coordinate of C, so that's 1, and from it subtract the x coordinate of B. So since B is x coordinate is -4, so we get negative of -4, that makes it +4. 1 plus 4 whole square. This will be added to the difference of the y coordinate, so we'll do 3/2 minus of -6, that means we have 3/2 plus 6 whole square. Let's find this value as well. So we get square root of 4 plus 1, that's 5. 5 square is 25. This is added to 3/2 plus 6, which will be 15/2. And squaring it gives us 225 divided by 4. Now this sum is going to be 5/2 multiplied to square root of 13. And then we find out the value of length CA. So CA is going to be equals to, we'll take the square root of difference of the x coordinate. So that's going to be 2 minus 1 whole square. Added to 3 minus 3/2, that's the difference of the y coordinate, and then square it. So this is going to give us a value, square root of 13/2. Now, square root of 117, that can be also simplified to get 3 times square root of 13. Now here, let's write down all the values. So we have found out that AB is 3 times square root of 13. So these are the values that we have obtained. BC, that's going to be 5/2 times square root of 13. And then we have CA, so CA is equals to square root of 13/2. Now clearly we are getting a relationship here. That means AB equals to BC plus CA. And since AB equals to BC plus CA, this only tells us that the 3 points are collinear. That means A, B, C, the points are collinear in nature. And if they are collinear, that means they cannot form a triangle. Therefore, we have successfully showed that the points A, B, and C cannot form the vertices of a triangle, hence proved.